The ground, this taconite is unsuited for AK Steel's productive blast furnaces. Pulverized and concentrated, the iron ore is fused back together as marble-sized pellets in the 4,000-degree inferno needed to reduce the ore to molten iron. Before the coal can begin the demanding task of smelting iron, it must be transformed into a more efficient form called. Completing the raw material list is limestone. Mined from quarries throughout the Midwest, this natural cleansing agent will collect the impurities released from the coke and ore. West Virginia coal, limestone from Kentucky, taconite from Minnesota, and a pinch of high-grade iron from South America.
Separate the iron-bearing particles, form the iron into pellets, and bake them hard. The bar production process often begins in Inland's electric furnace steel-making shop.
One of the big advantages of steel.
Large amounts of carefully selected scrap are charged into the electric furnace. Giant electrodes are then lowered into the chamber, and in 2 hours, the intense heat produced by the arcing between the electrodes and scrap.
Born of brittle, brute strength, the iron is destined for refining school, where it will learn to be rolled, drawn, and stretched as steel. Sun itself, AK Steel's metallurgical chefs keep sentry over their bubbling recipe. A sample from the molten bath is retrieved. In the shop's metallurgical lab, quality control technicians analyze and record the composition of the metal.
A supersonic blast of pure oxygen is blown into the furnace, producing a powerful chemical reaction at temperatures above 3,000 degrees. Once the steel is tapped from the electric furnace, it moves to the ladle metallurgy station for fine-tuning. And then on to quality and formability. To achieve those standards, the steel is tapped from the BOF and second snorkel. Alloys are added to the ultra-clean steel in an oxygen...
And it's a good thing, too, because the continuous caster at Ashland has the healthiest appetite in the world for steel. Delicate touch, hoist the ladle 4 stories high.
Degassing produces clean, ultra-low carbon steels that customers can form into complex shapes previously unattainable. It also assures superior quality for electrical steels used in high-efficiency motors. Fine-tuned, the molten steel is ready for shaping in one of Inland's 4 continuous casters, which turn out slabs, blooms, and billets. Continuous casting enhances...
Built to produce steel for pipe, this caster was actually mothballed a few years ago when the need for oil and gas pipe all but disappeared. In what resembles a chess move designed for giants, a new heat of steel is traded for the empty ladle. The tundish, still full of molten steel, continues to feed the caster during the ladle change. Atop the caster, a gate is opened at the bottom of the ladle. Liquid steel flows through a shroud into a trough, called a tundish, at a rate of 5 tons per minute. Nozzles in the bottom of the tundish direct the steel into water-cooled molds. As the steel
Jets of water remove surface scale from the steel as it moves through the rolling stands. Sensing devices continuously transmit the slab's thickness, width, temperature, and squeezing force of the rolls. Just 4 minutes, that 9-inch thick slab is rolled into a coil of